Hi! Today, we will learn about similar triangles. The following are the triangle similarity theorems. First, we have the AA similarity theorem or angle-angle similarity theorem. Next, we have the SAS similarity theorem or side-angle-side similarity theorem. And the third one is the SSS similarity theorem or the side-side-side similarity theorem. Let's discuss one by one. The AA similarity theorem or angle-angle similarity theorem states that two triangles are similar if two angles of one triangle are congruent to two angles of another triangle. Say for example, we have the given figure. Triangle WRS is similar to triangle BVS because of the AA postulate or AA similarity theorem. As you can see in the given figure, two angles of one triangle are congruent to two angles of the other triangle. Next, we have the SAS similarity theorem or SAS similarity theorem. It states that two triangles are similar if an angle of one triangle is congruent to an angle of another triangle, and the sides including the angles are proportional. So say for example, we have triangle CUP and triangle TEA. Let us get the ratios of the corresponding sides. So we have 16:12 and 28:21. So if we will reduce the lowest term, the given ratios of the corresponding sides, we have 16/12, divide both by 4, we get 4:3. Same with 28:21, divide both by 7, we have 4:3. So as you can see, the corresponding sides are proportional. So we can say that triangle TEA is similar to triangle CUP because of the SAS postulate or SAS similarity theorem. Next, we have the SSS or side-side-side similarity theorem. It states that two triangles are similar if the corresponding sides of two triangles are proportional. Say for example, we have triangle ABC and triangle QRS. So if we will get the ratios of the corresponding sides, we have 3:15, 4:20, and 6:30. If we will simplify the given ratios, we have 1:5. So as you can see, the ratios of the corresponding sides are equal or the corresponding sides are proportional. Therefore, we can say that triangle ABC is similar to triangle QRS because of the SSS postulate or SSS similarity theorem. Are the following triangles similar? If so, what similarity statement can be made? Name the postulate or theorem you used. In the given figure, yes, triangle FGH is similar to triangle KJH by AA similarity theorem. Vertical angles are congruent. Since FG is parallel to JK, we can say that alternate interior angles are congruent. These angles are also congruent. Angle J is congruent to angle G, and angle F is congruent to angle K. Therefore, the two triangles are similar by AA. Are the following triangles similar? If so, what similarity statement can be made? Name the postulate or theorem you used. The two triangles are similar by SSS similarity. Let us show that the corresponding sides are proportional. 5:10, 6:12, and 9:18. If we will simplify the ratios of the corresponding sides, we have 1:2, 1:2, 1:2. The ratios of the corresponding sides are equal, or they are proportional. Therefore, we can say the triangle ABC is similar to triangle DEF by the SSS similarity theorem. Are the following triangles similar? If so, what similarity statement can be made? Name the postulate or theorem you used. So we have triangle MOR and triangle GHI. As you can see, they have one congruent angle, which is angle O and angle H. Both measure 90 degrees. This time, let us check if the corresponding sides are proportional, or if the ratio of the corresponding sides are equal. So first we have 6:3. If we simplify this given ratio, we have 2:1. Next we have 10:4. If we simplify this given ratio, we have 5:2. So as you can see, the ratio 2:1 is not equal to the ratio 5:2. Therefore, the corresponding sides are not proportional. Therefore, we can say that no, these triangles are not similar. Are the following triangles similar? If so, what similarity statement can be made? Name the postulate or theorem you used. So in order for us to visualize the given figure, let us draw the two triangles separately. First, we have triangle AXY. AX measures 20, AY measures 25. And then for the larger triangle, we have triangle ABC. AB measures 20 plus 25, so that is 45. AC measures 25 plus 30, 55. We can say that angle XAY is congruent to angle BAC. This time, let's check if the corresponding sides are proportional. So first we have the ratio 20:45. If we simplify this, divide both by 5, we have 4:9. Next, corresponding sides, we have 25:55. Divide both by 5, we have 5:11. So as you can see, the two ratios are not equal, or the corresponding sides are not proportional. Therefore, we can say that the two triangles are not similar. Explain why these triangles are similar, then find the value of x. Okay, as you can see in the given figure, if you will try to observe, these lines are parallel. Since these lines are parallel, we can consider these angles as corresponding angles. Therefore, they are congruent. Another pair of corresponding angles that are congruent are these angles. Therefore, we can say that the two triangles are similar because of the AA postulate. Now, if we are to find the value of x, okay, let us first separate the two triangles in order for us to better visualize them. So for the smaller triangle, this side measures 6, and then this measures 9. And then for the larger triangle, this side measures 6 plus 2, and that is 8. And then this is x. So in order for us to solve for x, we form a proportion out of the given corresponding sides. So we have 6 is to 8 is equal to 9 is to x. Cross multiply, we have 6x is equal to 9 times 8, 72. Divide both sides by 6. Therefore, x is equal to 12. Another example. Explain why these triangles are similar, then find the value of x. Again, since these are parallel to each other, the corresponding angles are congruent. This angle is congruent to this angle, and this angle is also congruent to this angle. The two triangles are similar again because of the AA postulate. Now, if we are to solve for the value of x, let us separate the two triangles in order to better visualize the given figures. For the smaller triangle, this side measures 4, this side measures 5. And then for the larger triangle, this side measures 15. And then for this side, we have the sum of 4 and x, or 4 plus x. To solve for x, let us form a proportion out of the given corresponding sides. So we have 5 is to 15 is equal to 4 is to 4 plus x. Cross multiply, we have 5 times 4 plus x is equal to 15 times 4, we have 60. By distributive property, we have 20 plus 5x is equal to 60. 5x is equal to 60 transpose 20, so we have minus 20. 5x is equal to 40. Divide both sides by 5. Therefore, x is equal to 8. Decide whether the two triangles are similar, not similar, or cannot be determined. For the first triangle, let us solve for angle A. We know that the sum of all the angles of a given triangle is equal to 180. So in order to find the measure of angle A, we subtract the sum of 92 and 57 from 180. The sum of 92 and 57 is 149. 180 minus 149 is equal to 31. Therefore, the measure of angle A is 31 degrees. While for the other triangle, 92 plus 41 is 133. Subtract 133 from 180, we get 47. Therefore, the measure of the third angle is 47 degrees. If you will try to observe, only one angle is congruent between the two triangles. Therefore, the two triangles are not similar. Given the triangles are similar, find the value of the variable. So first, let us form a proportion out of the given corresponding sides. So we have 8 is to m is equal to 11 is to 6. Cross multiply, we have 11m is equal to 48. And then to solve for m, divide both sides by 11. Therefore, the value of the variable m is 48 over 11. Triangle ABC is similar to triangle DBE. So it is given that the two triangles are similar. Let us now solve for the value of the variables x and y. So we can split the two figures to better visualize. So for the smaller triangle, we have triangle DBE, and then for the larger one, we have ABC. Side DB measures Y, side DE measures X, and side BE measures 8. For triangle ABC, AC measures 9. BC measures 8 plus 4, so we have 12. And then AB measures Y plus 5. Let us first solve for the variable x. So in order to solve for x, let us form a proportion from the corresponding sides. Let's first have 8 is to 12. Equate it to corresponding sides having the variable x. So we have x is to 9. Cross multiply, we have 12x is equal to 8 times 9, 72. Divide both sides by 12. Therefore, x is equal to 6. Next, let us solve for the variable y. So in order to solve for y, again, let us form a proportion from the given corresponding sides. Again, we have 8 is to 12, but this time we will equate it to the corresponding sides having the variable y. So we have y is to y plus 5. Cross multiply, so we have 12y is equal to 8 times y plus 5. Apply distributive property, we have 8 times y is 8y, 8 times 5 is 40. Let us transpose 8y to the left side of the equation, so we have 12y minus 8y is equal to 40. 12y minus 8y is 4y, and then divide both sides by 4. Therefore, y is equal to 40 divided by 4, 10. X is equal to 6 and y is equal to 10. Thank you very much for listening. God bless you.